Thank you. Okay, 3.6 cube factoring. So what does a cube actually look like? Squared means something with a power of 2, so something that's a cube is a power of 3. So we're going to be factoring things that are powers of 3. Most important thing we always want to check for is a GCF. So you will always check for a GCF first. And actually that's just our general rule for factoring always, is that you are going to have to look for a GCF first before you try any other method. Okay? Otherwise our method, our shortcut methods won't work. Okay? For factoring cubes, we have a little acronym you need to remember. So, same, opposite, always positive. And that refers to the symbols or the signs inside of the parentheses after we factor. Okay, so I'll show you what it looks like when we actually do a problem. I just want to make sure that you guys have it written down. Okay, so it refers to the signs inside the parentheses after we start factoring these things. Okay. So remember how we had a difference of 2 squares and that was it? It was only worked if we had 2 squares that were being subtracted. For cubes, we actually have 2 rules. First one is called a sum of 2 cubes, which means we're taking 2 cubes and we're adding them together. Okay. What we're going to do for all of these is every time we recognize a perfect cube, we're actually going to rewrite it so that we have a base to the 3rd power. So we're actually going to be working with these bases. So every time that we see a sum of 2 cubes or a difference of 2 cubes, we're going to rewrite it as a base to the 3rd power. Okay? And here's where that SOAP comes in. Our signs inside of the parentheses are always going to show up as same. So my original problem was addition, so my first sign is addition. The next one is the opposite, so in this case it will be subtraction. And then the last one is always positive. Okay? So what we're going to do when we start factoring these things is we're going to write our parentheses and put in the signs first. Then we're going to fill in blanks, okay? So in our blanks, in the smaller parentheses, is just base 1 and base 2. So we're actually not even worrying about the cubes anymore. So when we're factoring these things, after we break it down to the base, we only care about the bases. We're not going to worry about the exponent of the 3rd anymore. So you take your first base and your second base, whatever those are, and those go inside. Next blank is the first base, just this part, all of it squared. Next blank is the first base times the second base. And then the last blank is the final base, all of that squared. Okay? Very similar rule to a difference of 2 cubes. So if we are taking 2 cubes and subtracting them, all of the blanks are filled in the exact same. First blank is base 1, base 2. Next blank is base 1 squared. Middle is base 1 times base 2. And then the last one is the second base squared. But our signs are different, so it is still the same. So when you are subtracting, it's minus. Opposite, so it becomes a positive. And then the last one is always positive. Okay, so those are our 2 rules. Okay, so example 1. We have x to the 3rd minus 8. Now this is a difference of 2 cubes because the 2 are being subtracted. But before we even start, I want to figure out what the bases are. X to the 3rd is already easy, it's already done for us, x to the 3rd. Minus, what is 8 written as a perfect cube? 2 to the 3rd power. So my first base is x, my second base is 2. So all we have to do is to factor this thing, and I want you guys to do this for every single problem, to break it up this way, because then it makes it really easy to identify what our bases are. Okay? So then, just like difference of 2 squares, I set up my 2 sets of parentheses, and for cubes, one is smaller and one is larger. And then the next thing I do is I fill in the sign. So this is a subtraction or a difference, so it's going to be the same, opposite, plus, and then always positive. So let's start filling in the blanks. According to our rule, the first blank is just the first base, which in this case is x. So we only care about the base now. The exponent does not make a difference. Next blank is base 2, which is a 2. Next blank, the first one in the larger parentheses, is base 1 squared, so that's going to be x squared. Next one is the two bases multiplied, so x times 2. And then the last one is the second base, 2 squared. But we have to simplify this all the way. So it's going to simplify down to x minus 2 times x squared plus 2x plus 2 squared gives me 4. Okay. Am I finished? Can I factor this thing? What method would I use? Diamond. Okay, so let's look at the diamond method. Can you guys think of two numbers that multiply to 4 and add up to 2?
1, 2, 3.
Multiply to 4 and add up to 2?
No.
Are there any?
No.
This can't be factored anymore, so you're done. Okay, and it's actually always going to work out that way. Okay, so you can do a quick mental check for yourself if you're ever unsure, but it will always be factored all of the way after that step. Okay, so example 2, we have 125 plus 27x to the third. (125 plus 27x to the third). These look like perfect cubes, but I don't know what the heck my bases are supposed to be, so let's actually rewrite it out. 125 is what cubed? 5 cubed. So rewrite it as 5 cubed plus, okay, 27x cubed. And here's where I see a lot of mistakes. Students automatically think that, okay, we already have the cubed here, so our base is just 27x. Not true. How can we break that up? 3x in parentheses, all of that cubed. Okay? So you need to make sure that you are sticking the entire base in parentheses, 3x, and then raising it to the third power. Because if I just gave you this problem 2 days ago, what would you have done with the exponent? This problem, if I gave you this one right here, you would have distributed the cube to get 3 cubed x cubed, which comes out to 27x cubed. Okay, so you need to make sure that you're breaking it down as much as possible. Okay, so 27 is also a perfect cube, so we have to make sure that our base, 3x, all stays together. Okay, so now we're going to use base 1, 5, and base 2, 3x inside the parentheses. So we set up 2 sets of parentheses. Same, plus, opposite, minus, always positive. Okay, first blank is just base 1, which is 5. Second blank is base 2, which is 3x. Next blank, the first one in the bigger parentheses, is base 1 squared, so that's 5 squared. Second blank in the big one is multiplying the two together, so 5 times 3x. And then the last one is 3x base 2, all of that squared. So make sure that you stick it inside of parentheses, please. Okay. And then now we have to simplify. 5 plus 3x times 5 squared gives me 25 minus 15x. 3x, all of that squared gives me plus 9x squared. And that's your answer. So example 3, we have a to the third, b to the third, plus c to the third. Alright, so we want to break these down first, so that we have single bases. So how could I rewrite a to the third, b to the third? So that we have just one base there.
A, B, C, third.
Excellent. A, B together, all of that to the third power. And then c to the third is already done for us. So what I want you guys to do right now by yourselves, we're going to set up a smaller parentheses and a larger one. I want you to fill in the signs for me. Okay, so this is a sum of two cubes, so my signs should be same, opposite, always positive. Okay, and then let's start filling stuff in. What is the first blank right here? We take the first base, A, B, and we just stick it in there. Okay, next blank is second base, so that's just C. In the larger parentheses, our first blank is going to be base 1, all of it squared. So make sure you put A, B in parentheses squared. The middle blank is base 1 times base 2, so it's just AB times C. And then the last one is second base C squared. So let's simplify a little bit. This is AB plus C. AB, all of it squared. How can I rewrite that? Well, it's written as AB squared. How can I rewrite it? A squared B squared. Good, thank you. A squared B squared minus ABC plus C squared. And that's your answer. So example 4, going back to working with numbers, we have 12 minus 12x to the third. Okay, 12 is definitely not a perfect cube, but what can I do before I even start? Factor out a GCF of 12. So factor out a 12, and that's going to give me 1 minus x cubed. Now do I have a difference of two cubes? Is 1 a perfect cube?
Yeah.
Yeah. So what I want you to do is literally rewrite it as 1 cubed minus x cubed. Okay. Because I want it to be obvious to you what the base is. Okay. Alright, so what is the first base in this case? 1, and what's the second base? X, okay? So what I want you guys to do now, we'll set up the parentheses, so a little 1 and a big 1. This is a difference, so I want you to fill out the rest. Okay, so how many of you wrote the 12 in front of all of your parentheses? If you forgot it, write it in now. That's a GCF. It does not go away. Our symbol should be negative, plus, plus. How many of you got all the signs correct? Excellent. Okay, what goes in that first blank? All right, who's in 35? What goes in the first blank? 1 minus x. Good. Okay, what about this blank right here? What goes right there? Who's in 8? Chris, what goes right here?
What?
A 1. What?
Square.
Squared. Okay. What about this blank right here? What goes in the second blank? Who's in 21? 1 times x. Beautiful. Okay, what about this blank right here? What goes there? Who's in 37? What? X squared. Perfect. Okay, now we need to simplify this. So this is going to simplify down to 12 times 1 minus x times 1 squared gives me 1 plus x squared. So that should be my answer. Okay. Alright guys, example 5. So we have 3y plus 81, y to the 4th.
Can we take all one or GCF?
Yes, we can take out a GCF. What would the GCF be?
3y.
3y. So let's take out a 3y. That's going to leave me with 1 plus 27y cubed. Okay, this obviously is not our base, so how would I rewrite that? That's going to be 3y times 1 cubed plus, how would I rewrite 27y cubed? We just did this. 3y parentheses cubed. Okay. Alright, so we need to rewrite 3y on the outside because that is our GCF and it doesn't go anywhere. Small parentheses, big one. This is addition, so same, opposite, always positive. What goes in the first blank right here? Who's in 4? Connor.
The first root.
The first, which is a 1. Good. What about the second blank? Anybody in? 33. Second blank is? Good, 3y. So we have 1 plus 3y in front. Okay, first blank in the bigger parentheses. Who's in 19? 1 squared. Perfect. Okay, second blank. Who's in 32? 1 times 3y. And then last blank is what? Who's in 22? It's 3y squared. Make sure 3y is in parentheses, okay? Okay, let's simplify. So we get 3y times 1 plus 3y. 1 squared gives me 1 minus 1 times 3y, 3y, plus 3y squared, plus 9y squared. Okay? Make sure that you do simplify. That's part of factoring. If you plug everything in correctly but leave your answer like this, I will take a point off because it's not simplified. Okay, so make sure that you simplify it all of the way. Okay, how do you guys feel about this now? Thumbs up or thumbs down?
Like a middle?
Or more in the middle?
More in the middle?
Okay, more practice. We're going to do one more.
Oh,
Okay, last example, well, second to last example. X to the 6th minus 8. 8 is clearly a perfect cube, but x to the 6th doesn't really look like a perfect cube. I know I'm going to have some base, all of that cubed. What would go inside the blank?
X.
What did you think? Say it again. Okay, if it's x cubed, that totally changes the value of this x to the 6th. What's the rule of a parentheses to an exponent? Do I multiply or add?
Add. Multiply.
Multiply. So what should it be inside? X squared. So our first base is x squared. Because if this was your problem last week, you would have multiplied 2 times 3 to get x to the 6th, right? So all we're doing is undoing it. So set up your parentheses. This is same, opposite, always positive. Okay, everybody, ladies and gentlemen, what is base 1 that goes right here? X squared. What goes right here? 2. In here is x squared squared. So make sure you put the original x squared in parentheses. And then our middle one is x squared times 2. And our last one is 2 squared. So simplify it. That gives us x squared minus 2. What's x squared? x to the 4th plus x squared times 2, 2x squared plus 4. There you go. Okay. Okay, the very last example is a word problem. It's a volume. Basically, you are given the volume of a prism and the height. Part A asks you to find the area, which we actually did last week. Part B asks you then to factor it out and find the possible length and width. So what I'm going to do is I want to pass out your quizzes so you can have them back. So what I want you all to do is while I'm passing back your quizzes, will you copy this down? It's all my work. It's the exact same process that we used last week for the same problem, except this time once we get the area, we have to factor it using cubes. Okay, so it's just a different type of factoring in step 2.